Okay, we are going to create a node type using Kotlin architecture. So Kotlin architecture has the inner cycle, which is entities, which is enterprise business rules, and one level of outer of the call is use cases, which is application business rules. And outer of that use case is controller presentation gateways. Outline is infrastructure, database, devices, web and UI and external interfaces. So it have these 5 rules like independent framework, testable. So the business rules can be tested without UI, database, web server, or any other external elements. So which the inner uh, business rule can be tested, use case and entity can be tested without the UI, database, web server, and any other external rules. And independent of UI, the UI can be changed easily. Independent of database, you can swap database like change with SQL Server, Oracle, MongoDB, and so on. Independent of external agency. So the dependency rules, which saying that the source code dependency can only point inwards. So the database point to that this interface adapter layer, use case point to that entity layer, and you cannot so the call doesn't have any dependency to use case. Use case doesn't have dependency to controller or presentation. Presentation can have dependency to use case. So let's start Android Studio. We are going to use room database, and we are going to the dependency injection. We are going to use Dagger Hilt, and let's start it. Is a new project. Oh, project empty activity, and let's save location to this Kotlin architecture. We say Kotlin architecture and API 24 minimal use Kotlin DSL. Finish. This. Okay, so now we have our application. Importing that Gradle protects take some time. Okay, so importing. Okay, so it's loaded, and we can go to Kotlin Java, and this is the unit test and the Android test. This is our source code. This is our main application, right? And this is the project level, the Kotlin Gradle file. And this is the app level. It's connected. We have these dependencies which are Kotlin, app cycle, Kotlin, activity, compose, bottom, UI, building, material 3, a unit, and so and test unit 2, and first. So the application runs, stop it, and first of all, we are going to create the enterprise business rule in, let's say we create a new package of domain, and in the domain we create a new package of model. This is a call, and inside this model we add a new Kotlin file of node, and this node is a data class, and the class which say we have one of ID int equal to 0, of title. Each node have a title, have a string, and we have one of content of string. We have one of timestamp of long. Okay, that's our call model, and so out of the model, we create a new package of repository. What was it? The repository, we say we have link of node repository, and this is interface. So this will be independent on the implementation of the repository, which can depends on different database, can have different repository, but it is in the domain, it is only provide the interface. So this we just say interface node repository, which we has suspend this asynchronous function from get nodes on which return list of nodes. Node is our model, and we can have suspend function of it node by ID. We provide a parameter of ID, and then we return a single node, which is optional. And we can have insert suspend function, insert node, we provide the parameter node type. We do return nothing, or we have suspend function, delete node, and provide a node. On the repository, and we have use cases. Look at a new package of use case. The use case is an application. This use case is application business rule. So here is use case, and we create. So first we only create a guide nodes use case. So this will be the application business rule. So this we say this application we want get nodes. So no matter the dependency of the database it is, but just get the nodes for us, and so we can change the database. So we will not depend on that. No dependency to specific data rules. So we can use dependency injection to specify which database we are going to use. So that's why we have a get node use case. So this get node use case will use case where we will inject we injected the repository over here. Repository which will be node repository. So no matter, so we because we have repository, so this use case will be independent of the repository because we use this dependency injection over here, and so in this case we can swipe the the depository easily, and this we just say get nodes. This we can say we use the invoke suspend operator and the function of invoke. We should return list of develop node, and this, so where we are here calling suspend operator for invoke, this which we will passing the function as arguments to other functions. So we are going to pass this function as arguments. And this we just say, because we have dependency of repository, we just say we return repository that knows. Okay, here we go. So that's our domain. And so for the database, we'll create a package, new package, Dagger, and the data we just say the local. We will say we are using for the new package of local. So local is this local device. We use room database, and to use that room database, we need a DAO, which is data access object, and let's say node DAO, and also we need node database. Node database, which will say we set up our room database, and we also need entity, node entity. So we use that room database and dependency injection. So we need project, we need Dagger Hilt for dependency injection. So plug project plug without Dagger Hilt Android. And for the app, right? Yes. What do we need? Is dependency injection. We need plugins of Kotlin kept. This is Kotlin annotation because it's use room table use annotation processing, and we need a Dagger Hilt for dependency injection. For the implementation, so let's say we need dependency injection, we need coroutine, we need room. So here, about the injection, and we can sync now. We got these dependencies set up, then we can go back to our the repository implementation. So let's we create a new package of the data repository. So this is our implementation of our room database. This. Okay. So now we have finished that sync of the dependencies. Feel successful. Okay, let's go back to our database access object. So that's we use annotation of DAO. So that's why we need is kept annotation processing. This plugin, and you can see that room database using the kept and implementation of room database. So let's say we have DAO import DAO, and this is not DAO, and this is interface. We need to provide this interface to room node DAO. And what we are going to do is annotation of query, and this query we can say import annotation. We got the SQL query, and let's say like star from nodes. This is our nodes table, room table. And this suspend function of right nodes, which is placed of node entity. And so right now we only have one interface for room database. Node DL is get nodes base, and node database. So this node database, we will say annotation of this is database, and which we say annotation, and we say entities. We specify the entities, and this is node entity, and which is class, and specify version equal to 1. And so this is abstract class. And this node base which will inherit room database. And this abstract will specify the abstract node DL, which is node our node DL, and for our node entity, this node entity, we just say that this is entity, is table, right? Entity of, and this table name, which is nodes, and the node is nodes, and this is data class. So for data class, we have say at primary key, and we say auto generated, auto true, and this var key of int equal to 0, and add all and count times time. So this entity is a room database table, DL data access, and database will specify the entity, the DL or here. They are connected to each other. So this the database entity, which is the tables, and data access object, and this is abstract class which inherit a room database. So the data access layer which are connected to the entity or this node room database. So that's how this local, and now we can go to the repository to implement the node repository implementation. So new there's learning class of node repository implementation. So definitely this implementation which we will say we have the dependency to DAO, right? Data access layer. DAO, which is node DAO. We injected this dependency data access object over here. And this we will inherit the interface of repository, node repository, implement members, and we are only going to say implement get nodes, and over here we say return DAO dot get nodes, and we say we return list of node, which is our domain model object of nodes, and we need map it to from entity to model, and so that's why we are going to say private function map node entity to model node, and provide entity of node entity, and return of node domain object. Then what's this map going to return node, and then the node which is ID of E entity parameter ID, which equal to title equal to entity of, and content that entity, well, entity is our parameter, and timestamp equal to entity of timestamp. Okay, so now we can see and call this get nodes map to nodes of entity. This DAO get nodes which return entities, and we call the high order function of map. Inside this high order function, it's an int a goes to. We call this map node entity to node. Goes to here, and this is entity. Okay, so now we get the nodes which is back to the domain model object. So this repository implementation will get nodes will return the domain object from database object. Okay, and we so next we are going to say we need a presentation layer. Create a new package. Presentation. And presentation we say new package. Notes list. Note list will have say we have a node screen, nodes screen, and for the node screen states we need a node state, and we need a view model node view model. This controller. And this. So the controllers over here will cause to the use case. In our case, is get nodes, right? So let's go to the nodes view model. First off, nodes view model. Then if we are going to use Hilt view model, and if view model is on so nodes view model. And this we need a dependency injection. We inject constructor, inject inject, and the constructor over here we say private or that those use case. So we pass this get use case function which does the invoke and pass it as a parameter, and we say this is get node use case. So this constructor at the dependency, you can see it has this level get dependency to use case and pass this use case. And so the use case layer will have no dependency to the outer circle of like controller presentation anyway, but the controller or presentation can have dependency on the use cases. We'll follow this up. And so this we can see this is inheritance of view model. The view model is Android Labs view model. And our view model will have that the dependency. This view model which say we have private. This not is private of state. So each view model have state and local, which is mutable. Mutable state flow of node state. Node state. So the mutable state flow is this is a mutable state flow. This flow, let's say, kind of broadcaster and subscribe item. So this will be the reactive UI, which will be say the subscribe any flow changes, and the subscriber can be will know that states change. And let's say raw is private will be say we have a public state which will kind of type of state flow type of node state, and which will be equal to, so this public will be passed to the node screen. And this, so now we can work on this node state. The node states will have UI states, and let's say it has where the UI states is loading. The kind of type of boolean equal to initial value of false. Data class, and this is parentheses, and this node states is the UI states of its loading. It's UI states of error string optional. Put it now. and which we have our the data of nodes of list of our model node model of node and initial value be list. And go back to this, and then now can see we have state, which is include the US this and data, and which is a state flow, which used for the our UI reactive UI. It depends on it can have different flow. Let's go back to the view model. This view model one unit, so constructor will get nodes. It's a function. So this will be private function get nodes. And this will be a routine view model stays model go view models launch. This is a coroutine. This will be inside. This will be a synchronous operation. So let's say first we say because we have access to the local database, room database, the state dot value which equal to state value copy is loading equal to true. Of course, we cited it's loading to true, and we try catch. We have a try catch block E for exception, and you know in this try catch block the only thing is loading. We need to after the operation we say this is loading. Its loading will be false. And what we are going to try is var nodes which equal to get node use case. We use the get node use case to get the nodes, which is a model list of model begin model or type of nodes, right? And during this state's value passed to the public state, and we say nodes equal to nodes. This nodes equal to nodes, and is loading to false. And if it's an exception, and this value which equal to this value dot copy. And in this case, we don't return nodes, we return error. Error is a string equal to message. Okay, so that's where we got our get nodes view mode, and work on the nodes screen. So for this node screen, we say this is a Jetpack compose, so it's composable, composable, which is fun. Node screen, and node screen. We need a dependency of view model, and which is nodes view model, and this will be called Hilt view model, and we'll use dependency injection. And over here we say this our raw screen state. This is by because this is reactive, so we should be view model public state, property of state. We need to collect as state, and then last over here we collected the view model state and collect as we need to import collect as states. So any view model change the flow change, and it will collect as states, and so it will be aware of the view model state change, flow change. So anything change, and this UI will be changed. And for this screen, we can just say our code scaffold, and the scaffold, let's say we have a top bar, and top bar equal to top bar, top bar. and the top variable has title equal to text notes. And you okay. So we have the top bar. And we are going to have floating action button floating. Floating action. Oh, this is floating button. And Optin experimental materials 3 application. Floating action button, we say floating action button. And on click, go to, we don't do handle the on click right now. And this text is class. We have a floating action button of I insert new note, but right now we don't do that. And we say over here, we can say padding goes to we use lazy column. And the lazy column is will need modifier equal to modifier. And the modifier will be max and padding of ID. And for this basic column, we have the items, state, and the view models, states of nodes, the data. And node, which goes to R. And so we import this foundation from these items. So in this, we pass the extension function. We pass the list of nodes over here. And we use the card specified modifier over here. Modifier equal to modifier but max and the padding. We say it.dp and then we say we have a column and modifier. We don't need max space. Modifier of 16 dp. And inside this column, we put types of title. Go to node title and style. Go to Nature, theme, typography, type, and we have spacer. Modifier, height. This spacer we have a height of 8 on dp, and we have text. Oh, let's say a copy. This will be the content. And this will be body medium. And you can see now we have the lazy column, and after that we check on the US state, if state dot error, we say state is loading on this, and we can see circular progress indicator, and state, we check on the null error, and we use slide to check on the error. If there's error, and we say error goes to, and we have text equal error, and color equal to material theme dot color scheme dot error. Okay, so that's our node screen, and you can see now we need a dependency injection which specifies the which database we are using, which repository we are using, and so we are going to create a new package, which is DI dependency injection, and inside this dependency injection, we say we set app module, and this is object app module, and we will say annotation of module Dagger module, and this will be this is singleton install in, and this singleton component. Singleton component, and so here what we are saying, first of all, we build the that abstract class of node database. So we provided this provide Dagger. This is singleton, and function provide nodes database. So that abstract class need to be instantiated into a physical room database, and this will it needed a parameter of application, and this is different application Android app of return the node database as singleton, and it will have instantiate of that the node database saying that event saying that will return a room database over here. Will return room dot database builder, and this database builder will pass parameter of this application, and node database. This node database is class object. This right class node database, and the database name of the room database of, let's say, nodes db, db, and this is a build this room database class, room database of nodes database class. And over here you see this need an application, so which we need to say we need to create a new Kotlin class of nodes type. This application nodes type. And this nodes type we just say we need to say Hilt Android app. So this Hilt Android is important, which the Hilt Dagger will know. This is an application. The annotation of this, and the Dagger Hilt will know this is the app. This app which implements application, and so this then it knows this is the annotation of Hilt Dagger app and app module, so it will do the autonomous dependency injection over here, and then it will build the nodes DB over here. And so we have the node type. Right. Node type. And we need a manifest. We say application. We need to say that Android name will be node type. This you need to specify in the Android manifest. And go back to that dependency. Well, first we have singleton our room database of nodes DB, which is the initiate created on the abstract class of node database, and So that you see a repository of nodes. DAO is an interface, and we need to that dependency injection need to know implementation of this node DAO. And go back to that what we say. Right. Alright. I should just copy a singleton. So we can copy this. So this will say provide node DAO, and node DAO, it has dependency of DB. The DB we have it over here, and that's DB is node database, and the return will be node DAO. Provide node DAO. The implementation on the room database, they still provide node DAO. They provide this interface instantiated class object, which is type of node DAO interface. We return this object, which is a database dot node DAO database data access object, and you can see we have a repository. So and we can say singleton, still singleton, so we can still use this provide singleton. This we will say provide node repository. Repository, the dependency is DAO of node DAO return the node repository, and then this will be return node repository implementation, and based on the DAO we passed. So this will provide a node repository implementation and based on the DAO, so one layer by another layer. And we got the node repository implementation, so we can pass it to the use case. Same thing is singleton, and we can say provide guide nodes use case, and it relies on repository. Repository that node repository, and it return get node use case. The node use case return is get node get nodes use case nodes use case passed by repository. Get nodes use case. Okay, so here, you can see we have all the dependency injections over this app module, and we need to go to the main activity. We need the main activity. We need to say this is a Hilt Dagger need to know annotation. Let's say this is Android intro point. Point. It's Hilt Dagger Hilt Android intro point. It's the Dagger Hilt need to know the application, and we create this and know the activity, which activity is Android intro point, and this is the main activity. So main activity, we can simply say in this clean architecture theme, we can say service and this service has modifier fail max size. And color material color scheme background, and over here we just say no screen and we can run our application. Okay, no screen model. else. And we can run. Okay, so everything works fine. Launching device. Install successfully. And we have the nodes. And we can go to view. And two windows. App inspection. And databases. Database inspector. And we see our nodes database. And table is empty. And that it has this works. Okay, so that's it all works, and let's say we can have nodes. So you can see it use this clean architecture. One benefit is independent of frameworks. You can change any framework later, like you can change Jetpack Compose if there's new frameworks available. And you can test the basically rules, no dependencies on database. You can change the database, for example, change from room to SQL Server or web server. So let's do some unit test. So let's go to the unit test. We have example unit test. So we can say run example unit test. And for the testing, we need these dependencies. We can copy. And then we can go to this. We can put in the dependency over here. So we are going to test the business rules. We just test the use case. So over here, a new Kotlin class, we can say that nodes use use case test. And that's one test pass. That's the example unit test. So get no use case test. Oh, we need sync our dependencies. We need a setup, so we have a private late init variable and this is repository need to be passed. This is node repository and we need private late init variable of that node use case. And what this we test on get nodes use case, and this we have a annotation of before JUnit, and this is from JUnit. So we say function setup. We set up the test setup, and this is a repository equal to markup. We have a markup of markup of the repository, and then we return get node use case, which equal to that node use case. We pass the marked repository over here, and so now we can test on this system to test is get node use case. We got the unit set up, and we say we have a test place test the unit test, and this function, and this guide nodes nodes return order based from repository tactic, and this equal to run test. Run test Kotlin routine test on run test. So this will say given this we have our marked nodes domain object those equal to list list of and it's domain object a1 and title and content one and another one. This is 2, title 2, content 2, step 1. And so query is saying this repository get nodes will always return our marked nodes. They always digital repositories get nodes function always return nodes. So use this code error, and that's the good markup of the repository. So when it calls to our result unit tests result is equal to get those use case. I call to this get unit test is get those use case, and then assert we see assert at result dot is equal to markup data nodes, and verify repository get nodes this code. Okay, now we can just run our unit test. And perfect, it's the test is passed, so it's run test. So you can see two tests passed. So result, so you can see use the clean architecture. You can see it's testable. So the business rule can be test without UI, database, web server, or any other external elements. And this is independent frameworks, so you can, no matter what, you can still use these domain objects. And independent of UI. But the UI can be changed easily. So because the UI will only access to the use cases, and independent of database, we can change the database over here, and after we change the database, we can just change the dependency injection over here. So if you want to change to other database, we can provide the database provide the database using the other one, and independent of any other external agencies. Okay, perfect. So that's our clean architecture node application.